we'll go for this Grayback normal form. I have discussed the Noam Chomsky has already defined the grammar as type 3, regular grammar. Type 2 is the context-free grammar. Context-free grammar, there is two prevalent form. One is Chomsky's normal form, that is the left-hand side one variable, right-hand side two variable, or only one terminal. And another is Grayback normal form. That is historical interest is there, but not much that practical use. So that I am describing right now. The Grayback normal form, it is like this, previous Grayback normal form. Here, the left hand side only one variable, and right hand side it must start with its terminal, one terminal only, and rest should be all variable, or it can be single terminal. That second rule is same as Chomsky's normal form, but Chomsky's normal form, right hand side only two variable, but here it should start with one terminal and rest of the variables. For certain top-down parsing, we'll discuss. So this will help for easily parsing. That is, parsing complexity may be less. For it can be proven for all good context-free grammar, maximum complexity should be O(n) cube. N is a number of terminals in the string, but we'll try to make it O(n) by different transformation of grammar by taking suitable grammar like LL1 grammar, but we can discuss it later in our compiler classes. But here we just want to show that basically these context-free grammar is the basic grounding rules for all our formal programming languages, or all programming languages like C, Java, like this. So the rule should look similar to programmers friendly. So this is Grayback normal form. Same thing, like this is not Grayback normal form. It can be easily shown, two terminals and two terminals here. This is Grayback normal form, and advantage of Grayback normal are very good for parsing. It is hard to find Grayback normal form. It is very difficult to find, but it is possible. Every context-free grammar can have one Grayback normal form, but it should be gated by I have to convert it to Chomsky's normal form, then Chomsky's normal form to Grayback normal form. That's the way. This recapitulates our Chomsky's normal form. This is main advantage of Chomsky's normal form. We can take the advantage of 2n minus 1 steps, and because it's a binary tree, but Grayback normal form, it's not binary tree. So that is the main advantage. Maximum 2n minus 1 steps, we can say that particular string is come from a particular grammar or not. The how to convert, why does JNF make some computation easier? Because it's first single terminal. By looking at the terminal from the start symbol, we can select our rules. How to convert CFG to JNF? Convert the first to Chomsky's normal form, as we have discussed in our last lecture. Then eliminate, this is the main topic, eliminate left recursion of the grammar possessive. If left recursion, because if the left hand side the variable say S, and right hand side variable also A starts with S, that's the left recursion. But our Chomsky's normal form doesn't prevent it, doesn't eliminate it, and we'll see it. So that we have to, but that is we can, left recursion is not allowed in Grayback normal form, but in Chomsky's normal form it is allowed. Like if we have this kind of rule, like this is left recursion, variable here and it occurs here, we can change by incorporating new variable B, this new variable, and incorporating these rules. So this original rule has to be rewritten with a new variable B with this rule. This is removing left recursion, like this rule I've discussed, and it is very simple example. This is a very common our formal thing, our programming languages, like expression with plus T. This is the product, and T, so that it has to be star, has to be product should be calculate first and then expression, and bracket should be first. So this is very in our programming languages it is available, and because E and E here, T and T here, it is not in Grayback normal form. I just give an example. To put it in a Grayback normal form, I have to put E dash and E dash extra variable so that it is right, and T dash also. So it is in Grayback normal form. But it looks very awkward. The rules looks very awkward and not programming friendly. So that is the reason this is for good for top-down parsing, and above one is the bottom-up parsing. We'll prefer that, not in Grayback normal form. So if you compare Chomsky's normal form and Grayback normal form, it is the famous algorithm, CYK algorithm is there. Maximum complexity O(n) cube. Here it is. It will much more than this. It no direct upper limit. Maybe O(n) cube or much more than this, and it is good for LL1 top-down parsing, and this is a bottom-up parsing. And we know that all our nowadays programming languages are bottom-up parsing, and it is much better. It can address more issues, like we have mentioned that natural looking languages. So Chomsky's normal form or bottom-up parsing is the preferred choice. There's another more simple function of Grayback normal form, that is S grammar, where the rules is like that. Like the right hand side, this rule, like a terminal, it is a Grayback normal form first of all, but there cannot be multiple rules starting with A. So it is very easy. If we look from the left hand side, we can always choose a rule. So we cannot have any rule start with A, because this is not a S grammar. It is a Grayback normal form, though it's a Grayback normal form. But it is in Grayback normal form, also in S grammar. It is very easy grammar. That is called simple grammar. So what is it? What is in the summary? We can say why does GNF make some computation easier? Because of this look ahead symbol, where left hand side we can choose the rule. What is the worst case time complexity from Chomsky's normal form to GNF? Generally O(n) cube, or it is like that. Can every CNF be converted to GNF? Yes. In fact, every context-free grammar can be converted to Chomsky's normal form. It can be converted to GNF. That is no issue. But grammar, if you have a different methods, grammar may looks like different, but they produce the same language. So that's it. There's not the unique conversion. It is not there. But to produce from CFG to GNF, we have to first convert to Chomsky's normal form, then Chomsky to GNF, and from GNF to CNF is also very possible by looking at it by removing the left recursion just I have shown. Thanks.